Hi, I'm Ms. Wong. We're going to solve trigonometric equations, and this is part 2, so slightly difficult questions. If you haven't seen part 1, watch the first one first. So we are looking at a sine nx and a cos nx kind of questions in this video. In the first video we looked at simpler questions where c is our value. So let's look at the first example. Find the solution to sine 2x equals minus a half, where x is between minus pi and pi. So previously we had a look at what happens if we have sine x equals to a value. Now we have sine 2x. So we know how to solve sine x equals to a value, so we're going to substitute, so we have a problem similar to that. So we substitute the 2x, let it equal to theta, and now if that's the case, then if x is between minus pi and pi, then 2x would be between minus 2 pi and 2 pi. So now that we have converted our question, it looks like this now. So instead of reading that with the 2 there, we have converted to sine theta equals minus half, where theta is between negative 2 pi and 2 pi. We know how to solve this from the previous video. So in this video, we just added an extra step. So let's solve this, and then we convert back to x. So let's solve for theta. So theta is sine theta is equal to a half when, let's use the triangle, and that is a half is opposite over hypotenuse, so we're looking at pi on 6. So the first quadrant angle is pi on 6, and it is negative or stationed to Caulfield, so we are negative in the third and fourth quadrant. So we have to find our values in the third and fourth. How do we go to third? We do pi plus the angle, so pi plus pi on 6, which is, well, 1 plus a 6 is 7 pi on 6. And the fourth quadrant is 2 pi minus the angle, so 2 pi minus pi on 6, 12 minus 1 is 11 pi on 6. And then we have to look at minus 2 pi to 2 pi. So we've done between 0 and 2 pi, now we have to go to the left, so we're subtracting. So minus a period, and the period, we're doing theta here, okay? Don't get confused with the question, we're just working with theta. The period for theta is 2 pi. So we have 7 pi on 6 minus 2 pi, which is 7 minus 12 is minus 5 pi on 6. And 11 pi on 6 minus 2 pi, 11 minus 12 is minus pi on 6. So that's minus pi on 6. So now we have the solutions for theta, which is minus 5 pi on 6, minus pi on 6, 7 pi on 6, and 11 pi on 6. Now that we have theta, we can go back to our original questions. So see, we've worked in theta, now we go and reconvert to x. So theta is equal to 2x. That means 1x is equal to, bring the 2 over, dividing by side by 2. And dividing by 2 is the same as multiplying the denominator by 2. So we have minus 5 pi over 12, minus pi over 12, 7 pi over 12, 11 pi over 12. So let me recap because there's a lot of steps. Step number 1, convert. So then your question is a lot easier to deal with. When you convert, you're not just converting the question but also the domain. So if x is equals to that, then 2x, you need to figure out what it's equal to. And then in your calculation, you can use your period to be normally like 2 pi because we're working in theta. And you need to add and subtract to get all your values within your domain. And once you've done that, then you can convert back to x. Let's do another one. Example 2. 2 cos x minus 1 equals theta, where x is between 0 and pi. First of all, we have to rearrange. We can clearly see that when we rearrange, we have 2 cos x equals 1, so cos x equals to 1 over 2. So now we have that question. We have to figure out the first quadrant angle, which is, well, adjacent over hypotenuse, means we're looking at this angle over here, pi on 3. So the graph looks like this. And we want when cos is positive, so all stationed to Caulfield, so it's first and fourth quadrant. So for the first quadrant, it's easy, it's pi on 3. For the fourth quadrant, we have, well, 2 pi minus pi on 3, which is 5 pi on 3. However, 5 pi on 3, it is inside or outside our domain? It's actually outside our domain because we only want between 0 and pi. So we realize that that is not part of our solution, and we have our answer to be just pi on 3. So you don't have to sketch the graph, but I'm just putting it there so you understand what's going on. But you can see that 5 pi on 3 is bigger than pi, so you would know to cancel that out. But keep on your working out to show that you were finding the quadrants where it was positive. Example 3. So same question, what happens if I put the domain as negative pi and pi? So again, we would rearrange to change the question, and we would find our first quadrant angle to be, this is the same question as before, but with a different domain. That's why I'm going a little bit faster. So adjacent over hypotenuse pi on 3. And then we would sketch our graph, this time between negative pi and pi. And we can see that our cos is positive, quadrant 1 and quadrant 4. But when we do quadrant 1, pi on 3, and quadrant 4, 2 pi minus pi on 3, 5 pi on 3, 5 pi on 3 is not inside the domain. So how do we go to this one? So the left of the left value. So we can see that we got the pi on 3, but we're missing this one. So we must subtract a period to find the other solutions, just like we did in the previous video. So we subtract a period from here, pi on 3 minus 2 pi, we realize we're minus 5 pi on 3. That's not actually what we want. So from here to a period, it's way far. So that's not the answer we want. But if we subtract a period from that quadrant, then 5 pi on 3 minus 2 pi. So 5 pi on 3 minus 6 is minus pi on 3. We get the other answer we want. So in this question, I want you to notice that when we're doing our quadrants, and we should keep our working out because we might use that quadrant to move left and right periods to find our other solution. So for this question, our solution is pi on 3 and minus pi on 3. If you're getting used to this, you could have just gone up that way and left because we're going pi and negative pi is our domain. So retry this question and try to understand and visualize the directions we're going and how to obtain these two answers quickly. Thank you for watching. I'll see you next time. Bye.